Hello everybody, welcome to lesson 4. Here we're going to be learning about the parabola and the circle. So what does a parabola look like? A downwards facing parabola looks like this, the red, and an upwards facing parabola looks like the blue. Now the vertex form, that looks something like this. Y equals x plus 4 squared plus 7. The vertex would be at -4, 7. The x-coordinate of the vertex is the negative of this number, and the y-coordinate of the vertex is the positive of this number. What questions can the SAT ask with the vertex form? They're pretty limited in this case. It either opens upwards or downwards, and the other question is, what is the maximum or the minimum point? So here, what makes this parabola open downwards? It's this negative sign. If there is a negative value in front of the x plus or x minus something squared, then it opens downwards. And it has a maximum point. Think about the red parabola here. It opens downwards and there's a maximum point. There is no minimum point because it extends downwards forever. What is the maximum point here? Well, that's just the vertex. -2, -5. The negative of this number and the positive of this number. Y equals x plus 2 squared minus 5. What makes this parabola open upwards? Just because there's no negative, or this is pretty much like a hidden positive here. What is the minimum point? Well, remember, it's the negative of this number and the positive of this number. So -2, -5. Does this parabola open upwards or downwards? Well, it opens upwards because there's no negative here. And what is the minimum point on this parabola? The negative of this number and the positive of this number. So 5, 3. This parabola opens downwards because of the negative, and the vertex, or the maximum point, is -5, -3. The quadratic form. What questions can the SAT ask with the quadratic form? How many solutions? What does a solution mean in terms of quadratic? Well, a lot of times the quadratic will be set equal to value. For example, x squared minus 4x plus 7 equals 12. This means that we have two equations in our system. One is a parabola, something like this, and another one is a line at 12, and we want to find how many times it hits that line. Now, there's a neat trick to finding how many solutions there are to a quadratic equation, and it only works when the quadratic is set equal to 0. So in this case up here, we'd have to subtract 12 from both sides. So we get x squared minus 4x minus 5 equals 0. Then we could use this trick. If b squared minus 4ac is negative, there's 0 solutions. If it's positive, 2, and if it's 0, there's 1. Every quadratic is in the form y equals ax squared plus bx plus c. And when I say b squared minus 4ac, it's just these. B squared here minus 4ac. How many solutions does this quadratic equation above have? So b squared is -4 squared, which is 16, minus 4, a is 1, c is 6. So 16 minus 24 is going to get us a negative number. So there's 0 solutions. What about this one? Remember, it has to be set equal to 0. So we have to subtract the 6 over to the other side to see how many solutions there are. So our new quadratic is x squared minus 4x minus 6 equals 0. B squared is 16 minus 4ac. -4 times -6 is going to be a positive number. And if we add that to another positive number, it's still going to be positive. So we have 2 solutions. What about this one? B squared, or -2 squared, is 4, minus 4, a is 1, c is 1. So 4 minus 4 is 0. And since b squared minus 4ac is 0, that means there's 1 solution, not 0. Don't be tricked up on that. What are the solutions, they could ask? There are 2 ways to finding the solutions to a quadratic. One is factoring. This also only works if the quadratic is set equal to 0. So let's look at the top case. We have to set this equal to 0. So how do you do that? Just add 8. X squared minus 6x plus 8 equals 0. Now, the way we factor is we're just trying to get two factors or things that multiply to become this. So we know that x times x is x squared. So if there's a 1x squared, like a hidden 1 here, we have to have x and x in the first part of the bubbles. Now we want to find two numbers that multiply to negative 8 and add to negative 6. So it has to add to the middle term and multiply to the last term. So those two numbers are negative 2 and negative 4 equals 0. And we could check to see if that's the correct factored form of this quadratic. We could just FOIL or box this out. I like foiling, so I'm going to FOIL it out. So x squared minus 4x minus 2x plus 8. That's x squared minus 6x plus 8. And that's the same thing that we had, so it works. So if x minus 2 times x minus 4 is 0, x could be either 2 or 4. So if x is either 2 or 4, then the quadratic x squared minus 6x plus 8 is equal to 0. So those are our two solutions. In this one, we have to find two numbers that add to 3 and multiply to negative 10. Well, we know it's going to be a negative times a positive because those are the only two types of numbers that multiply to negative 10. And I see that positive 5 and negative 2 work. So if this is equal to 0, then x is either 2 or negative 5. The quadratic formula is another way. This is negative b plus or minus the square root of b squared minus 4ac over 2a. And when should you use this? When you can't factor, or when the answer, specifically in multiple choice, has a radical in it. For instance, if answer choice A, B, and C are negative 2 plus root 5, negative 2 minus root 5, negative 3 plus root 7, then you know that you should use quadratic formula. So this also only works when the quadratic is set equal to 0. So let's do it. Negative b is negative 3 plus or minus the square root of b squared minus 4ac over 2a, or 2 times 1. So we have 3 plus or minus the square root of 9 minus negative 20. So 9 plus 20 is 29 over 2. Now there's two solutions. This is when you have 3 plus the square root of 9 over 22, and you have 3 minus the square root of 9 over 29 over 2. Those are the two possible solutions. So remember, it has to be set equal to 0, the quadratic, so we could subtract 10 to the other side to set it equal to 0. Negative b plus or minus the square root of b squared minus 4ac over 2a. So we have negative 1 plus or minus the square root. So we have 1 minus negative 40. So we have 1 plus 40 is 41 over 2. Now there's two solutions here. That's negative 1 plus the square root of 41 over 2, and negative 1 minus the square root of 1 over 41 over 2. They could also ask, what is the minimum point? So what is special about the expression x squared minus 10x plus 25? Well, it's a perfect square. Let's try to factor it. What two numbers multiply to positive 25 and add to negative 10? Well, that's negative 5 and negative 5. So this expression could be written as x minus 5 squared. That's going to be important in finding the minimum point on parabolas that are in the quadratic form. So what is the minimum point here? Well, that's simple, just 4 comma negative 10. Now here, we can't just say the vertex or the minimum point is 4 comma negative 10. It doesn't work like that. We have to get from the quadratic form to the vertex form. So how do we do that? We complete the square. First, you could set equal the quadratic. You could set that equal to 0. Then you add the constant over to the other side, so x squared minus 4x equals 10. Now we want to complete the square. We want to make this left side here a perfect square. A perfect square occurs, for instance, for like in this example, when the third term is equal to the second term, the b term, divided by 2 squared. So in this case, you have negative 10 divided by 2 is negative 5, squared is 25. So in this case, negative 4x, our b term is negative 4, divided by 2 is negative 2, squared is 4. So if we have something that looks like this, x squared minus 4x plus 4, that's a perfect square that we could factor into x minus 2 squared. So what do we have to do to get that? Add 4 to both sides. So we know that this left side over here factors to x minus 2 squared, and that right side is 14. Now subtract the 14 to the other side and set it back equal to y. Now we have our equation in vertex form. And here it's clear that the minimum point is the vertex, 2 comma negative 14. What is the minimum point here? Negative 6 comma negative 4. Now, what is the minimum point on this parabola? To find it, we have to complete the square. X squared plus 6x minus 4 equals 0. Now, we have to divide the b term, the term in front of the x, by 2, then square it, and we have to add that value to both sides. So 6 divided by 2 is 3, squared is 9. So if we add 9 to both sides, the left side factors nicely into x plus 3 squared, and the right side is 13. Subtract 13 over, and set it back equal to y. Vertex here, it's pretty easy to see, is negative 3 comma negative 13. Now the circle. The center is the negative of this, so 8 comma negative 6. And the radius is the square root of this last term here, so 5. I'll give you another example. X plus 4 squared plus y minus 1 squared equals 64. The center here would be negative 4 comma 1, and the radius is the square root of this number. So the square root of 64 is 8. I'll give you one more example just to make it abundantly clear. X plus 7 squared plus y plus 6 squared equals 9. The center would be negative 7 comma negative 6, and the radius is 3. Okay. Now that was really easy to do because it's in this form where we have two perfect squares equal to a value. Here, we don't have that, so let's try to get it in that form. As in finding the vertex for the parabola, we're going to subtract the constant to the other side. So x squared plus 6x plus y squared minus 10x equals negative 18. Now, when we complete the square, remember that the b term, the term in front of the x, when we divide that by 2 and we square that, that should be added to what we already have to get a perfect square. So here, we've x squared plus 6x. 6 divided by 2 is 3, squared is 9. So if we add 9 here, we got to add 9 here. Negative 10 divided by 2 is negative 5, squared is 25. So we got to add 25 here. So now, it works out nicely because we have two perfect squares. x plus 3 squared plus y minus 5 squared. And if we evaluate this, this is negative 9 plus 25 is 16. And we can see here the center is at negative 3 comma 5, and the radius is the square root of 16, which is 4. That's lesson 4. Hope you learned something.